Okay, let's move on now to section 1.5, conditional statements. You might be surprised that you've heard this already. You're familiar with conditional statements, maybe just not the terms that we are going to use. Conditional statements are frequently given in if-then form. Here are some examples of conditional statements. Now, one of the first things here, we need to talk about the form and keep whether the statement is true or false separate. Let's not be distracted by whether the statement is true or false if we're talking about the form of these statements. We'll talk about it later. Don't worry, we'll get there. Be patient. If it is raining, then it is spring. That's an if-then statement. You could argue about cause and effect, but it is a conditional statement. If x and y are both whole numbers, then the difference, x minus y, is a whole number. If water is heated, then it boils. These are all examples of conditional statements. The first part usually involves the word if, is called the hypothesis. The second part, usually involving the word then, is the conclusion. And then we have symbolic form. Okay, so you're going to need to get used to seeing these. The blue printed there, letter P, and the red Q, again, both lowercase, with that little arrow is the symbol that we use for a conditional statement, if P, then Q. Notice the little arrow only goes in one direction. You can register to vote if you are at least 18 years old. Now that's not in strict conditional form. Usually with conditional statements, we start with the word if. We don't have it in the middle of the sentence. So again, let's distinguish here in that sentence. You can register to vote if you are at least 18 years old. The hypothesis part of that is at the end. You are at least 18 years old. That's the hypothesis. If we can meet that, then we can move on to the conclusion part. Here is actually written first, and the sentence does not include the word then anywhere. So to put this in strict conditional form, we need to rewrite it and say, if you are at least 18 years old, then you may register to vote. I'm not sure why they changed the verb from can to may. Don't know. Try not to do that, okay? Try and use the same verbs, the same terms that they do, if all we're doing here is rewriting things. Then we can talk about whether or not it's true. And again, in logic, we have the somewhat fancier term, we will determine the truth value. It just means figuring out if the statement is true or false. Now again, in our study of logic, a truth table will show us exactly what's supposed to happen, right? So for most people, that first line and that second line makes sense. If the hypothesis is true and the conclusion are true, then we can say the entire conditional statement is true. If a number is evenly divisible by, if a number is divisible by 2, then it is an even number. If the hypothesis is true but the conclusion is false, then we say that the entire conditional statement is false. If we go back to those examples in the very start here, if it is raining, then it is spring. Well, okay, it rained the other day, but it's definitely not spring. So we say the entire conditional statement then is false. Okay. Now, these next two kind of mess with your brains at first. If the hypothesis of the statement is false, but the conclusion is true, then we say that the truth value of that conditional statement is actually true. If it is the year 1723, then you are in honors geometry. The first part's obviously false. It is not that year. But the second part's true. You are in honors geometry, so we would say that that statement is true. I know it's going to mess with your minds. Work on it a little bit. That third line is usually the most difficult. The fourth line here, if the first statement is false and the second statement is false, it is logically consistent. So we say that the conditional statement is true. All right, let's take a look at if a number is even, then it is divisible by 2. Well, okay, let's look at maybe some examples there. If a number is even, 16, 58. Any number that you can come up with that qualifies as an even number, then yes, it is divisible by 2. So the first part is true. The second part is true. So we say that the conditional itself is true. Once we have a conditional statement, then we start messing around with it. Okay, you'll notice here, if P then Q is our normal form for a conditional statement. The converse of a conditional statement will reverse the order of the hypothesis and conclusion. So if P then Q becomes if Q then P. Here's another term that you need to know, negation. Gives you the opposite meaning of the original statement. If you are a freshman, the negation would be if you are not a freshman. Frequently, all we really need to do is flip the verb. If it says is, we change it to is not. If it's written in the negative, then we change it to positive. Sometimes, though, let's give it some thought. If a number is even, the negation of that, I would prefer that you give that a little bit more thought rather than just writing down if it is even, the negation, if it is not even. Oh, wait, hold on. If it's not even, the negation of that really should be it is odd. Okay. So if we take the original statement, the conditional if P then Q, we keep the order the same, but we negate both parts. That's what we call an inverse. An inverse is obtained by negating both the hypothesis and the conclusion. And because, yeah, we're mathematicians, we like to play around with stuff. The contrapositive is a combination of doing both the converse and the inverse. We negate both parts and flip the order. Okay? So, given a conditional statement, we should be able to write out the converse, the inverse, and the contrapositive. If you play the trumpet, then you play a brass instrument. That's our conditional statement. Okay? Now, the first part of it here asks you to write the converse of the condition. Remember, converse, we're going to keep the ideas just the way they are, but reverse the order of them in our new sentence. So yeah, technically here, the hypothesis is you play the trumpet. Technically, the hypothesis does not include the word if. The conclusion does not include the word then. In this case, our conclusion is the idea you play a brass instrument. So the converse of if you play the trumpet, then you play a brass instrument becomes if you play a brass instrument, then you play the trumpet. Now notice here how with the converse, it's written like another conditional statement. We start with if, include the word then almost in the middle of the sentence. And what we've done with the converse is reverse those ideas that were in the hypothesis and conclusion. Okay, so is the original statement true? If you play the trumpet, then you play a brass instrument. Yes, that's true. That's our definition there. A brass instrument, a trumpet, is a type of that. So the original, the hypothesis is true, and the conclusion is true, so the statement is true. For the converse, if you play a brass instrument, then you play the trumpet, that's false. There are more brass instruments than just the trumpet. Okay, so if we're trying to determine truth value here, if the first part is true and the second part is false, we say the statement is false. So again, if you want to go back and look at that truth table from earlier, that might help. If two whole numbers are even, then their sum is even.
Write and determine the truth value of the inverse and contrapositive of the conditional. If two whole numbers are both even, then their sum is even. Using the given conditional, we can designate P as the statement, two whole numbers are both even. Likewise, we can designate Q as the statement, the sum of two whole numbers is even. The negation of P, called not P, is two whole numbers are not both even. Similarly, the negation of Q, called not Q, is the sum of two whole numbers is not even. The two statement negations can form two conditionals, the inverse and the contrapositive. The inverse statement, if not P, then not Q, is if two whole numbers are not both even, then their sum is not even. The inverse is false because a counterexample exists. For example, 3 plus 5 equals 8. Whole numbers 3 and 5 are not both even, but their sum is even. Finally, the contrapositive statement of if not Q, then not P is if the sum of two whole numbers is not even, then the numbers are not both even. The contrapositive is true because whenever the sum of two numbers is not even, one of the numbers must be odd. For example, 7 equals 1 plus 6. 7 equals 2 plus 5. 7 equals 3 plus 4. Since no counterexample exists, the contrapositive is true.
Okay, so let me re-emphasize here. If you're trying to determine if it's true or false, a false statement has at least one counterexample. Really, one counterexample is all you need to say that a statement is false. If a statement is true, there are no counterexamples. So frequently, you got the implication here yet? Frequently, it's easier to prove that a statement is true because you just need one instance. You need one counterexample to prove that it's false. to prove that a statement is true, you need to prove that it's always true. You need to show that no counterexample exists. Okay, so that can be a little bit tricky. Okay, and the last new term that we're going to throw at you here is a biconditional. If the original statement, if P then Q, is true, and its converse, if Q then P, again, don't get converse and inverse mixed up here. If the converse is also true, then we can combine those two sentences into one sentence called a biconditional. Hopefully you guys are familiar with conjunction junction. We are going to take those two ideas of P and Q and connect them with the magic phrase, if and only if. That's going to be in the middle of our sentence there. We're not going to start a biconditional with the word if. We are not going to write the word then anywhere. Okay, so then here we have the lovely truth table here for biconditionals. No, again, no, I'm sorry. Notice also the symbol has changed for a biconditional, 2 arrows, because it's true going in either direction. A marine biologist writes this conditional. If a seahorse gives birth, then it is a male. Well, that's true. Don't know if you knew that about seahorses. Only the males can become pregnant and give birth. Should a marine biologist state this as a biconditional? Well, okay, the original statement there, if P then Q, is true. If a seahorse gives birth, then it is male. So that's what we're going to use for P. That's going to be a seahorse gives birth. Q is going to be a seahorse is male. So writing out the biconditional here, okay? Again, make sure that you catch the format. A seahorse gives birth if and only if it is male. Now in this case, you can see up above there with the lovely color coding, they used the word seahorse in each of those. You really don't need to. We could, at times here, use pronouns. You don't have to write that out. A seahorse gives birth if and only if a seahorse is male. Okay. Caution, don't use the pronouns until the second part. Don't say, if it gives birth, then it is a male. That's not specific enough. And please, please, don't use the word you. If you are a triangle, then your angles add up to 180. No, I am not a triangle. Will you knock it off? No. So the original statement, if a seahorse gives birth, then it is male. That's true. But wait, hold on. If a seahorse is male, then it gives birth? That's not necessarily true. I imagine we could find pretty easily an example of a seahorse that is male that has never yet given birth. Okay? So the biconditional in this state, in this sense, is false. Okay? Again, for the biconditional to be true, both the original conditional statement and its converse both need to be true. All right, so if you're still with me here, let's go the other way. If you're given a biconditional, first of all, you can only write that biconditional if it's a true statement. Okay? We should be able to take any biconditional and split it apart into the two conditional statements. So let's take a look at this example. A triangle is equilateral if and only if it has three congruent sides. So we should be able to split that up. The one idea is a triangle is equilateral. The other idea is that a triangle has three congruent sides. So we should be able to write a conditional. Notice here how we're again back to starting the sentence with the word if. We're back to including the word then. If a triangle is equilateral, then it has three congruent sides. In the other conditional, if a triangle has three congruent sides, then it is equilateral. And hopefully, without too much argument, we understand that both of those conditional statements are true. That's why the biconditional up at the top is also true. Okay, so this is a lot of writing once we get to the quiz. Once we get to the test, what you will find, why are we even doing this, Mr. Mark? A lot of the theorems that we're going to talk about are written in conditional form. And if we can consider the truth value and the converse is also true, that'll tell us something interesting about the figures that we're going to study. Okay? So that's why we're taking the time here to go through the formats and look at a bit of logic and talk about whether statements are true or false. So this is going to be practice of writing these things out. For this part of our next quiz that's coming up, oh, I don't know, not this week, but probably next week. Yeah, be prepared to do lots of writing on your paper. All right, that's pretty much it. Again, if you take a look at the Realize website, you should be able to find the assignment here from lesson 1-5, and we'll talk about any questions that you have later.